Okay, hello students. So today we are going to see how to synthesize a cDNA. So for the cDNA we need to do the reverse transcription polymerase chain reaction. So it's a combination of reverse transcriptase reaction, okay, where we just convert the RNA into DNA. Okay, that is a complementary DNA, and then we amplify a specific DNA target using a polymerase chain reaction. So we are going to see only the first part, that is we are going to synthesize the cDNA from a total RNA. So I think in the last class they have taught you about how to purify the total RNA and quantify the RNA. So today we are going to see about what is reverse transcriptase PCR. So here what we do is, first we isolate the RNA, that is what we have already done. Okay, so that will be converted into a cDNA using an enzyme called reverse transcriptase. So this reverse transcriptase is an enzyme which will synthesize the DNA using a RNA as a template. Okay, that's why they called as a RNA dependent DNA polymerase. So this process is called as reverse transcription. So whatever the complementary DNA that is synthesized in this method, that can be used for the amplification process or even for to study the gene expression. Okay, so here we use a different type of primers. Okay, so we use a oligo T, okay, or we use a random hexamer, or in some case we can also use a sequence specific primer. Okay, this is what the principle is. So you will have a mRNA. So in the mRNA you need to add a primer, so that you need some starting material, right? So for that they use a primer like your normal PCR. So here there are three type of primers, that is what they use it. One is a gene specific primer, or oligonucleotide, oligo DT, or random hexamer. You just see where they go and bind. So gene specific primer will just go and bind to your particular gene where it is complementary, whereas oligo T, it's bind to the mRNA where you have a poly A, that region they will go bind, whereas random hexamer, it will just go randomly and bind in the RNA copy. So that will be converted, that is used as your starting material, and then the reverse transcriptase will synthesize a new DNA using RNA as a template. So whatever you get at the end of the this reverse transcriptase reaction is a cDNA. Then the cDNA will be used for the PCR amplification. So what are the materials required for this reverse transcriptase reaction? So we need a plastic tubes. So usually PCR tubes, they will use it, 20 microliter reaction volume, that is what we are going to do it. So then we need a genomic DNA removal mix. So this is, it's a nothing but it's a mixture of DNAs, and also it will have a RNase inhibitor. So why they use this genomic DNA removal mix is so that if there is any genomic DNA contamination is there, that will be removed by these DNAs, so that the genomic DNA will be degraded by this DNase enzyme. And also if there is any RNase is there, what happens is that will degrade the RNA. So actually we synthesize the DNA from the RNA, right? So but if the RNA is present, what happens is it will just degrade all your RNA. So in order to avoid that, we also include the RNase inhibitor. So this will inhibit the RNase enzyme. Okay, so third thing is we need a reverse transcriptase enzyme. That is the enzyme which is going to synthesize your cDNA using RNA as a template. And also next is reverse transcriptase mix buffer. So where you will have a optimized concentration of oligo, TT and random primers. So here the primer will be already present in the reverse transcriptase mix buffer, and also the magnesium ion as well as the DNTPs. So magnesium ion is very essential for the enzyme activity, and also the DNTPs are the one which is going to add it to the cDNA. And then you need a RNase free water. So it's a molecular biology grade water, so it is free of any enzyme, DNA or RNA degrading enzyme nucleus. Then ice, PCR cycler, thermocycler or heat block, and water bath, vortex and microcentrifuge. So these are the things that is necessary for doing your experiments. So procedure. So this is a flow chart which gives you the overall procedure. First, what you have to do is you need to make the first reaction mix. That is, we need to remove the genomic DNA from your sample, right? So for that, first we need to mix that RNA. Then you need to add genomic DNA removal mix and make up the volume to RNase free water. So here how much amount of your RNA you will take, what is the volume of the RNA you will take, it depends upon the concentration of your RNA. Okay, so based on that you need to choose your concentration. Next you will add genomic DNA removal mix, and then you make up the volume to 15 microliter. I'll give you the table where you can find the exact volume. And then you need to incubate it for the 45 degrees Celsius for 2 minutes. Okay, and then you need to place it on the ice. So this is the first incubation. Next, after you remove from the ice, what you need to do is you need to add the reverse transcriptase enzyme, that is 1 microliter and 4 microliter of reverse transcription mix. So totally 5 plus 25, so 15. So there you will get a final volume of 20 microliter. So this will be mixed and then incubated at 25 degrees Celsius for 3 minutes, and then that is the annealing temperature, and 45 minutes for 10 minutes. So this is for the synthesis of your cDNA. And then you need to incubate at 85 degrees Celsius for 5 minutes to inactivate the reverse transcriptase. So we need to inactivate the enzyme, so we need to incubate at 85 degrees Celsius for 5 minutes. Then after that you can just take this cDNA and then you can perform the real-time PCR, or you can just do any PCR for amplification of your particular gene using a gene specific primer. Okay, so this is the first table, that is for the preparation of genomic DNA removal reaction component. So what are the things you will add? I said you need to add a DNA removal mix, that is 2 microliter, and template RNA. So it depends on the concentration of your RNA. So if it is total RNA, it's including mRNA, tRNA, rRNA, all the RNA, in that case it should be less than equal to 5 microgram. Whereas if you have a purified mRNA, in that case you need to add less than equal to 1 microgram and make up the volume with the RNase free water to 15 microliter. So this is the first reaction you need to make it, and this is the second table. Okay, so which will give you the reaction mix for cDNA synthesis. That is, you have that first I mean entire genomic DNA elimination reaction, that is 15 microliter, right? Plus reverse transcriptase mix, that is 4 microliter, and reverse transcriptation enzyme, that is 1 microliter. So totally 20 reaction microliter. So this is what you need to keep it in the thermocycler, that is 20 microliter. So next, this is what the different incubation time. Okay, just see here the genomic DNA elimination reaction. So it's at 2 minutes at 45 degrees Celsius. So this is the reaction mix, that is 15 microliter, that is you need to keep it for 45 minutes for 2 minutes. Then you need to keep it in a ice. Okay, after removing from the ice, you need to do the reverse transcription reaction, where the annealing step is 3 minutes at 25 degrees Celsius, reverse transcriptation step 10 minutes at 45 degrees Celsius, and inactivation of the reaction 5 minutes at 85 degrees Celsius. So this is what the principle and the procedure for your cDNA synthesis. Now we look into the video where we shown how to perform the okay, now we will see how to perform the experiment. First, you need to take all the reagents and you need to thaw it and place it on the ice. Okay, next we need to prepare that genomic DNA removal reaction. Okay, for that you need to take 2 microliter of genomic DNA removal mix, so which includes your DNase and RNase inhibitor. So in these reactions where we are doing it here, the concentration of the RNA is between 10 picogram to 5 microgram. Okay, so that is the total RNA. So if you're using a more than 5 microgram RNA, or a template volume exceeds 12 microliter, then you need to scale it according to that. For example, if you're using 10 microgram of RNA and double the volume of all the reaction compound except the double the volume and do not exceed the final volume of 30 microliter. So to this, I mean, after you're taking a genomic DNA mix, you need to add the RNA, so which depends on the RNA concentration. So up to 5 microgram you can add it. Okay, to this you need to add RNase free water, so that you need to make up the total reaction volume to 50 microliter. For example, if you are taking 2 microliter of your genomic DNA removal mix and you are taking some 4 microliter of your RNA, then 4 plus 2, it's become a 6. So remaining 9 microliter water you need to add it. So I'm just adding a water to make up the volume to 15 microliter. After that, I'll just spin a tube for a few seconds, and then I need to incubate for 2 minutes at 45 degrees Celsius. So I'm just keeping it at 45 degrees Celsius for 2 minutes, and then I need to take it and place it immediately on the ice. So here I'm just keep it on ice box. Now I need to prepare the reverse transcription master mix. So according to the table I need to do it, I mean table 2. So where you have to add reverse transcriptase enzyme 1 microliter, and 4 microliter of reverse transcription mix. 4 microliter of reverse transcription mix. So it's 5 microliter, right? So if I'm going to do more than one reaction, for example, if I want to take do a 10 reactions, means in that case I need to take a volume for 11 reactions. So that one reaction volume is for if there is any pipetting error. So in that case, if I want to do for a 10 reaction, I need to take for 11 reaction. That means reverse transcriptase enzyme 11 microliter, and then reverse transcription mix 44 microliter. So from that I can take 5 microliter and put it in each reaction. I'll just do a spin so that it mixes well. Then I need to add this reverse transcription master mix to the entire genomic DNA elimination reaction. So that is what I got it in the third step. So that is having a template DNA, right? So in that I need to add it. So now the total volume becomes 20 microliter. Then that tube should be placed in the thermocycler. So in the thermocycler, the temperature what you have to set is, for annealing temperature you need to set 25 degrees Celsius for 3 minutes, and reverse transcription step 10 minutes 45 degrees Celsius, and inactivation of the enzyme, okay, that is done at 85 degrees Celsius for 5 minutes. So once the reaction is completed, then you can take it and store it in the fridge, or you can use it for gene expression studies or amplification of a particular gene using a gene specific primer.